Okay, we're going to talk about strong acids and strong bases. This is basically just a list of things to memorize. So strong acids. You are familiar with some of these already. And I'm just going to list them out, like I said, just a list of things to memorize. Hydrochloric acid, HCl. HBr, hydrobromic acid. HI, this is hydroiodic acid. Alright, and there are 4 more. Kind of depends on who you ask if there's 3 more or 4 more and what book you look in. It doesn't really matter. We have HNO3 nitric acid. Then there's H2SO4, which is sulfuric acid. And then there is HClO4 perchloric acid, and finally there is HClO3 chloric acid. Now this last one, chloric acid, depends on what book you look in. Some books list it as a strong acid, some books don't. I don't know. There's always goofy stuff like that. Now, you're probably familiar with 3 of these, and that's because chemists use 3 of these when we need a strong acid. There's different reasons to use them one over the other, but hydrochloric acid we use all the time, nitric acid we'll use all the time, and sulfuric acid we'll use all the time. The other 4, you just don't run into that much as a chemist, okay? If you're actually doing lab chemistry. But that's not to say that they're not important. They are strong acids. And the important thing to remember is if something is a weak acid, it's not on this list. So anything that is an acid starts with H, or has the carboxylic acid group, like we talked about the other day. If it starts with H, has a carboxylic acid group, but is not on this list, it's a weak acid, plain and simple. Okay, bases. Strong bases. Oh, let me scroll back up for just a moment. Look at the strong acids. Okay, a lot of these things you'll see on your solubility rules as things that are always soluble. No coincidence. Okay, and hydrochloric acid, hydrobromic acid, hydroiodic acid, they're one right on top of the other in terms of the anion on the periodic table, so not super complicated to memorize. Strong bases, though. Let's talk about those. Okay, we have, these are all hydroxides. Lithium hydroxide, I'm not going to spell them out. Sodium hydroxide, potassium hydroxide, rubidium hydroxide, and cesium hydroxide. Again, those are all alkali metals. That's why they're alkali metals. Okay, they make alkaline compounds. And also we have calcium hydroxide, strontium hydroxide, and barium hydroxide. Those are alkaline earth metals, except for the top 2, barium and magnesium. I'm sorry, beryllium and magnesium. Barium's on there. Now, what makes a weak base. Okay, weak bases. Keep hitting the erase button while I'm writing. We talked about this a little bit the other day. Weak bases are not one of those. So if it's a hydroxide, but contain hydroxide, something like FeOH3 ZnOH2 ... Okay, etc., etc. And then we talked about the nitrogen-containing compounds the other day as well. I know this is a lot to take in all at once, but you just got to work on them. So if you see nitrogen, think base. Remember I told you the other day NH3, and that was in the previous video. Okay, and also amines. So like methylamine. Alright, one more thing in this video, and that's what we call polyprotic acids. Okay, polyprotic acids, the word poly, or the prefix poly means many, protic refers to protons, so these are acids with multiple protons. And there's a few of them that you probably want to know. H2SO4. So there's 2 protons, that's what makes it polyprotic. Phosphoric acid, H3PO4. We could go on and on. Chromic acid, H2CrO4. ...